Okay, so let's see if we can graph a hyperbola when we know its equation. So the first thing is we know this is a hyperbola because it has x squared and y squared, and they are separated by a minus. If this were a plus, this would be an ellipse. Alright, so it's important to understand this equation. The first thing is the center. We don't have shifted x's and y's. We simply have x squared and y squared. So the center is the origin for this particular hyperbola. And I apologize now if I occasionally call it an ellipse. I tend to do that for some reason. I can't get it out of my head. So the first thing we'll do is we'll graph that center, and that's a good place to start because that's where all of our measurements will begin. So here's our center. And now I need to know how far to measure from my center up, down, left, and right, the 4 points, right? So those distances come from these numbers. These are the distances squared, so I have to take the square roots of them to get my distances. So this would be a 3 distance, this would be the square root of 11 distance. And this is, this is a little bigger than 3 if you wanted to look at it. So what happens is 3 is associated with the horizontal variable x. So I'm going to go 3 units horizontally. So I'll go 3 to the right, and I'll go 3 to the left. Square root of 11 is associated with the vertical variable y. So I will go vertically square root of 11. So I'll go up square root of 11, and I'll go down square root of 11. Okay? And now, what this allows me to do is it allows me to graph my asymptotes. My asymptotes can be drawn by rising and running. So I'll rise up to the square root of 11 and I'll run to the 3. And now I've got my center and I've got this red point. I can draw this asymptote, this diagonal line. I can get my other asymptote by starting at my center and rising to the square root of 11 and running to the negative 3. Now I have to decide, are my vertices going to be the square roots of 11 or the negative 3 and positive 3? So when we look at the equation, notice the positive term is the x term. That tells us that the vertices are going to be horizontal from each other because they're with the horizontal variable. The horizontal variable is positive, if you will. So my vertices will be here and here. Another way you can verify that is this point is 3, 0. That point should make this equation true. So when you plug in 3 for x and 0 for y, it should make it true. And it does. You may want to pause and verify that very quickly. It's also true that this point, this ordered pair, is 0, square root of 11. This x and y value do not make this equation true, so you should verify that as well. Since it doesn't make the equation true, this cannot be a point on the graph. So the square roots of 11 are not actually on the graph. They were there just to help us graph the asymptotes. So the hyperbola is going to go through these vertices and approach our asymptotes, something like this, on each side. And now I need my foci. First of all, let's label. The vertices are plus or minus 3, 0. The asymptotes are lines. So they have an equation like y equals mx. So y equals the slope. Well, the slope is rise over run. So my rise, I start at the center, I rise square root of 11, and I run 3. So my slope is square root of 11 over 3. And my other slope is rise square root of 11 and run negative 3. So it's plus or minus square root of 11 over 3 times x. And my center is the origin, so I don't need an x plus or minus something or a y plus or minus something to shift the asymptotes. Finally, the foci are here and here, so I need to find how far they are from the center, so I'll call that distance f. And we know that f squared is the 3 squared plus the square root of 11 squared. So that's 9 plus 11 is f squared. So f is the square root of 20. So this distance f is the square root of 20, and so is this distance. So my foci are plus or minus square root of 20, 0.